So welcome to the video. Today we're going to focus on onboard diagnostic data, shortened to OBD, and we're going to take a look at the extraction and the analysis of this data. So what is OBD? OBD is a type of data that's accessible from almost every modern vehicle. It provides large recordings of engine health, fuel efficiency, and so on. And the intended use is for mechanics to diagnose issues with the car. For example, if a check engine light comes on, the mechanic can connect to this port and they'll get codes explaining the issue. So here we have the history of OBD. You can see in the early 90s it was introduced for emissions control. Then OBD2 got developed and became mandatory for all new US cars and trucks. And it just keeps evolving. And we can see in 2010 it's mandatory for all heavy duty vehicles, so basically every vehicle requires one these days. So why is this useful in a forensic investigation? One of the reasons is it stores pre-crash and crash data. So you can see the speed, the braking, the throttle position, steering input, airbag deployment, and all this is useful for piecing together what happened in a crash. Another reason why this is useful is for fraud detection. One example of this is odometer rollback. This is where the mileage clock in a car is changed. So, example, if you've got 100,000 miles, you could change it to 80,000, which would increase the value of your car, but it's technically fraud. And ECU reprogramming. This is where the engine is tuned to often increase power or throttle. This makes the car more powerful, often faster. But it's technically insurance fraud if you don't tell your insurance provider because your car is more powerful than what they think it is. And it's also used to detect disabled emission systems. An example of this is the Volkswagen scandal, where they purposely lowered their emissions during tests. And that's just to name a few. So accessing the OBD data, it's always accessible from a port. It's normally located under the steering wheel, as we can see here. This car's a left-hand drive. In the UK we've got right-hand drives, so it'd be mirrored. You can see it's under a little port we just lift up and plug straight in. It can vary between models, but it's normally always under the steering wheel like that. So here's two types of connectors. The first is a very basic one, just a USB one. So that just plugs straight into the port and straight into your computer. And then on the right we can see one of the latest developments is a Bluetooth connector. So you plug it into the car and then you've got an app which shows you data, as we can see here. Here's a breakdown of the port itself. We can see the different pins and what they do. So we've got the power, we've got the CAN. So all of this is sending different data basically. So extracting OBD data, there's a range of different software tools that we can use. A lot of these are dependent on the vehicle model. So a software called VCDS focuses on Volkswagen vehicles, because often the data sent is different between models. As we saw earlier, there's also mobile applications that are available. So now we're going to look at a pre-extracted OBD dataset. You can download this from the site. And this was extracted using an ELM327 connector and was connected to an Android phone running an app called Android OBD Reader. And here's a picture of the ELM37. So here we have an example OBD dataset in Excel. So you've got a wide range of headings and a lot of data. So this is a recording from a single trip. See, there's plenty of data for us. And on the first column we have engine runtime in seconds. So this tells us the duration of the trip, and we can map out each data point to the exact time. So now we're going to take a look at why this data is useful. In relation to engine and vehicle operation, we have engine runtime. This tells us the duration of the trip. And engine revolutions per minute. This can show if the vehicle is accelerated hard before an event. And vehicle speed, which is obviously crucial for accident investigations. Next we have throttle and fuel usage. Throttle percentage tells us whether the driver is accelerating or decelerating. Engine load percentage tells us the stress levels of an engine and can be used to detect aggressive driving. And we have fuel tank level and fuel air equivalence ratio, which can tell us about fuel issues and is useful for diagnosing mechanical issues. A common theme with a lot of this data is it's designed for mechanics. So a lot of it may not be directly useful to an investigation, but there are a few important parts we can pick out. So next we have temperature and pressure sensors. We have coolant temperature. This indicates engine heat levels and is useful for mechanical issues. Then intake manifold pressure and intake air temperature, which are both useful for diagnosing issues with these areas. It can also help assess the efficiency of the car. And we've got a maintenance and trouble code section. So the first we'll look at is time ran with malfunction indicator light on. So this will be a check engine light on your dashboard. It tells us how long the vehicle's been running with this light on. So this could tell us that the driver's been running with this light on, which is indicating an issue, but they've not got it checked, which could result in a mechanical failure. And time since trouble codes have been cleared. This basically tells us when the last issue was cleared. And the distance travelled with MIL on. Same with the first part we looked at. This just shows how far the car's gone, which can also be used to detect if the driver's just ignored this light. And then warm up since code cleared. This helps determine whether the OBD system has been cleared recently. And catalyst and emissions data. Catalyst temperature, which is part of the exhaust. It shows us useful data for emissions testing and can analyse exhaust performance. Then commanded evaporative purge. This helps to detect fuel vapour recovery system issues. So, why is this data useful for us? So from the top we've got accident reconstruction. Speed, throttle and RPM can be used to paint a picture of a driver's behaviour before an accident. We can see if they're driving rash or fast, which is obviously useful. Then fraud detection. We can see how recently codes have been cleared, which could reveal tampering. And theft investigation. With engine runtime and distance travelled, you can help piece together a vehicle's movement after it's been stolen. And maintenance disputes. This helps to prove if a fault existed at a certain time or mileage. So, for example, if you've bought a car and an issue arises, you could check this data to see if the issue existed before you bought the car, and the seller didn't state this to you. So, in conclusion, we saw how to extract and interpret OBD data and the range of information that this data source provides to us. And we also looked at how this data can be applied to a forensic investigation. Thank you for watching. I'll see you in the next video.